I would like to continue with part 2 of my course, that is the rapid crown prep. I just discussed about the core buildup. Now I would like to show you a video that will clear your concepts.
Sometimes when a tooth is broken off due to a fracture or decay, there's simply not enough tooth remaining to place a crown. Fortunately, there is a way to replace the missing portion and save the tooth. By bonding one of the new plastic resin filling materials and building the tooth back up prior to preparing it for a crown.
There are two primary requirements for crown prep. First is the restorability of the tooth, that is the cuspal coverage, as you can see in the picture. And second is the ferrule. Ferrule is a very important part for placing the crown. It is actually a ring or a cap, typically a metal one, that strengthens the end of a handle, stick, or tube and prevents it from splitting. As you can see in a picture, a pencil with a metal band. As with pencil, the metal band helps to connect the wooden part of the pencil with the rubber. Similar is with the tooth. The metal band in the pencil acts as a ferrule in the tooth. As we can see, the width of the ferrule, that is approximately around 2 millimeters, that is required. Ferrule is the presence of 1 to 2 millimeters sound structure at the cervical area of parallel axial walls that totally encircles the tooth. As in the picture, we can see the ferrule part and the core buildup part. In order to ensure the success of the crown, we need to make sure that crown goes beyond the core buildup. Importance of ferrule. It provides bracing or casting action to protect the integrity of the root. Crowns whose margins encompass a ferrule alter the distribution of forces, as ferrule is very important to distribute the forces, otherwise fractures may occur. These restorations have a subgingival collar that acts as a hugging action and prevents vertical fracture of the tooth. Ferrule design and fracture resistance of an endodontically treated tooth. According to the study, it is evaluated that the fracture resistance of a pulpless teeth with various ferrule designs and amount of coronal tooth structure. According to the research, it stated that 1 millimeter of coronal tooth structure above the crown margin substantially increased the fracture resistance of an endodontically treated tooth. As we all know, that it mostly is applied to the posterior teeth, as they are not substantial to shear forces like the interior teeth. Now we are going for the steps of crown prep. If we talk about posterior teeth, we all already know of how to do crown preps. Therefore, there are different materials like porcelain fused metal, ceramic crowns, metal crowns, gold crowns, and there is something new to the field, that is zirconia. Zirconia requires just a little different prep reduction if we compare to other materials. If we are talking about zirconia, then it is a very strong material with good strength, but it is a bit brittle. Therefore, in order to prevent zirconia from fracture, we need at least 1 millimeter of reduction at the line angles. Otherwise, at the trying stage of crown, it might fracture. I also need 1.5 to 2 millimeter of occlusal reduction. And if I talk about axial surfaces and buccal and lingual surfaces, it requires at least 1 to 1.5 millimeter of reduction with a chamfer margin, and the taper has to be around 4 to 6 degrees. If I talk about interior teeth, it's pretty much the same. That is around 1.5 to 2 millimeter of incisal reduction and 1.5 millimeter of axial wall reduction with 1 to 1.5 millimeter labial or lingual wall reduction. Internal line angle should be rounded and make a chamfer finish line. Finish line. There are three most common finish lines that we know in the crown prep. That is the supragingival margin, subgingival, and equigingival margin. It is ideal if we can keep the crown supragingival, as it is the best margin, as it saves time and the gingiva is always much happier around natural teeth than metal or porcelain. But if the aesthetic area comes over, it's better to go subgingivally, but not more than 1 millimeter, as it is very important to preserve the biological area of the tooth. Technique used for rapid crown prep. For preparing the crown, we are going to use the peeling the enamel technique. It includes the following steps. It's very easy to follow these steps. Firstly, we are going to use carbide burr, and we are going to place the carbide burr on the enamel, and we have to move 2 millimeter gingival to the cement on enamel junction and move the burr in the direction opposite to the rotation of the burr. This will peel the enamel from the surface. Then we have to follow these steps for all the surfaces, that is facial, lingual, and proximal, and occlusal surfaces. Now the question arises that what burrs should we use? Diamonds don't work well with this technique. With diamonds, you're just wasting your time grinding through a lot of enamel that is eventually going to be gone anyway. More recently, crosscuts and innovative attack angles were introduced to the carbide cutting shank to make the preparation better, faster, and easier. Like the great white shark burr, as it results in a better preparation. It's faster and saves time, and cutting is much easier as compared to diamond burr. The standards of dental care have evolved rapidly over the past 50 years. Today's best practice modalities require both tooth conservation and clinical efficiency. The dental profession tends to take burrs for granted. They are frequently used for patient treatment every day, and their effectiveness and efficiency can have dramatic impact on the practice. The clinical efficiency of the preparation is largely dependent on the shape and design of the cutting burr. As clinical efficiency is increased with faster and more aggressive cutting tools. These burrs were preferable to steel for high-speed tooth prep. The subsequent introduction of carbide cutting instruments was a leap forward for dentistry. Carbide offered more effective tooth prep with less surface styration than diamonds. More recently, crosscuts and innovative attack angles were introduced to the carbide cutting shank to make the preparation better, faster, and easier. The more often that the dentist must change burrs during tooth cutting, as it becomes more time-consuming process and less efficient the technique. As we can see in the picture, the carbide burr, it's dentated and it is specifically designed for superb cutting action. It has a smooth tip that helps to ensure martial integrity, and it cuts fast with minimal clogging. Complete the bulk reduction process with one instrument. Crown prep. The initial step for crown prep with the peeling the enamel technique is by creating depth cuts. So the total reduction that we have to do is around 1.5 to 2 millimeters. So we make depth cut of about 1 millimeter. So we are left with only 1 millimeter of total approximate reduction. So it will be easily done while finishing the tooth. We will peel the enamel this way after creating depth cuts, and peeling the enamel removes the enamel from the dentine very nicely using the carbide burr. This carbide has a smooth round tip and is dentated. That makes the cutting very fast. After carbide, we use the chamfer burr so that we can refine the prep that we have already done, and it works rapidly. High-speed handpiece with burr performance. Cable optic torque handpiece is being used for this purpose, as it is a high-speed handpiece and it has 20% higher torque than the old style handpiece. It has 4 cooling pods. The cooling pods helps to reduce the temperature and prevents from pulp damage. If there is an obstruction of coolant from 3 of the ports, you always have at least 1 pot cooling the burr. So it's very helpful having 4 cooling pods. Research studies shows that the performance of diamonds versus dentated carbide burrs in the following areas, that is the weight advancement, in the load required, operator's pressure, and rate of load required, ease of instrument requirement, and RPM. That is checking the torque of the handpiece, rotation of the burr, and the ability of the burr to clean itself. These all areas are checked and the performance is verified. The high-speed handpiece and the burr performance of the burr contribute to this rapid crown prep. Weight advancement results. According to research, dentated carbide burrs were shown to cut between 11.5% to 35.3% faster than all major diamond competitors. Researchers say that dentated carbide burrs can save clinicians about 1.15 minutes to 3.53 minutes when cutting a 10-minute crown prep when compared to diamonds in the study.